All right, so we're talking about word problems. We've done word problems before, so I know you guys know about the let statement and therefore statement. I'm going to review that with you. We're just going to do 4 questions together today. We're going to do 2 number problems and then 2 perimeter problems. And like I said before, the rest of the class will be yours to practice. So let's look at the first question. For every single one of the questions, I have provided the answers in brackets. So if you're wondering what those random numbers are, it's the answer. The question says the sum of 2 numbers is 46. What does the word sum mean? Erie? Sum, yep, tell me in terms of an operation sign. Addition, yeah, good. So the sum means we're adding 2 numbers together and the answer is going to be 46. One number is 12 more than the other. What are the numbers? Okay, so here's how I approach the question. The first thing I do is I think logically. I know I have the first number and I have the second number. We know we have 2 numbers. I'm going to call the first number x. And once I put down a letter, I have to define it. So I'm going to say let x, did we do let statements before? Good. Let x represent the first number. You guys will remember that for word problems, you can actually get like a lot of marks without even solving the question. Have a let statement, have a therefore statement, have some sort of answer, a check, etc. All right, so if my first number is an x, the question also says one number is 12 more than the other. So what do you think I can write to represent the second number? 12x is 12 times x. We want the number to be 12 more than it. Saoirse? X plus 12. Good. Think about it. Does it make sense? Okay, good. So one number is x, the other number is x plus 12. Now the question says the sum of these 2 numbers is 46. So what are we going to do? We're going to take the first number, add the second number, and let it equal to 46. Good. All right, so let's set that up. I always like to keep these in brackets. So I'm going to say the first number is x plus the second number is x plus 12, and it's going to equal to 46. We all know how to solve this, right? Why do I keep it in brackets? Because sometimes the question can be tricky and say like the sum of 2 times the numbers or something like that. I'm going to not give you tricky questions like that, but I just keep it in brackets anyways. I'm going to open up the brackets because all the numbers in the front are 1. So it's going to be x plus 12 is equal to 46. X plus x is 2x. Move the 12 over to the other side. So it's going to be 46 minus 12. This is going to be 34. And what is our value for x? Good job. 34 divided by 2 is just going to be 17. Did I do that too quickly or does it make sense? Yeah, of course. So what have we just found? What did we just find with this x is equal to 17? We found the first number is 17. What is the second number going to be? Yeah, it's going to be x plus 12. So it's going to be 17 plus 12, which is, yeah, and I noticed I made a mistake here. This actually should not be 19. It should be 29. Okay, now we have to do a check. Remember, have I taught you guys how to do a check yet? We did a check for our last word problem, right? No. Okay, so here's what I do. I call this section my check section, but it's not going to be a left side, right side check. So I know you're groaning, but you don't have to because we're not going to do a formal check. We're going to do just like a logical check. I know the first number is 17. I know the second number is 29. If I add these up, what should it equal? 46. So let me add this up. 7 plus 9 is 6. Carry the 1. 1 plus 1 plus 2 is 4. And so this actually makes logical sense. If the first number is 17 and the second number is 29, then both of those will add up to 46, which is what the question is asking for. And that's really the only check I require, a logical check. But I do want to see something here. So if you don't put anything where you've checked your work, then you will lose marks for it. But it doesn't have to be like a formal left side, right side check. They'll always be nice like that. Yes, okay. We need a therefore statement for the end. So we're going to say therefore, your therefore statement always needs to answer the question. So the question is, what are the numbers? The numbers are 17 and 29. All right, for question number 2, it says one number is 5 more than another number. So again, I'm going to call the first number x, and I will call the second number what? X plus 5. I need a let statement. I'm going to try to keep the same color theme. So I'm going to go with green. And again, I'm going to say let x represent the first number. Okay, now this equation ends up being a little trickier. Let's see what it says. It says 3 times the first number plus twice the second number is 30. Find the numbers. How would you figure that out as an equation, Nicole? Excellent. That is perfect. And now do you guys see why in the first question I kept everything in brackets? Because for some questions, you're going to have a number in the front. That's why I kind of just make it a practice to always keep it in brackets. All right. I'm assuming you solved this and got an answer. So I'll do the same. 3x plus 2x plus 10 is equal to 30. 5x is going to be equal to 20 because I'll move the 10 over and subtract it. And then did you guys get x is equal to 4 as one of your numbers? Yes, you did. Okay. All right, now we can go to the side and do our check. So for my check, again, it's not a formal check, it's an informal check. I'm just using logic and trying to see if this answer makes sense. I know my first number has to be a 4, right? Because the first number is an x and we just figured out x is equal to 4. What will the second number be? Which is 9, good. Okay. Now again, we're using an informal check. Let's see what the question says. 3 times the first number. So what's 3 times the first number? It'll be 3 times 4 plus twice the second number. So it's going to be 2 times 9, right? Our first number is 4, so I did 3 times 4. Our second number is 9, I did 2 times 9. And this should equal 30. So we get 12 plus 18, which equals 30. And so our answer is correct. Anyone confused as to how I got this as an answer? Does it make sense? Great. Now, all we're missing is a therefore statement. So we're going to say, therefore, the numbers are 4 and 9.